Understand it?
Yes.
So the special first thing in the Emsat, and the first thing you need to know all over, the first thing which is the states of matter. So what does that mean by states of matter? You need to identify the states of matter, differentiate between if the solid is of the substance is solid or liquid or a gas or even a plasma. So here, when we have the all particles that just made up of motion and the continuous motion, and this motion completely continuous, never stop. So here, if you got a solid substance, this solid substance, you just become as particles, and each particle can stick together with the other particle, which is mean like we can have them, they are fixed shape, I mean like definite shape and definite volume at the same. So all particles are just sticky together. At the same time, you can find them as a pattern. They have pattern. Got it?
Yes.
Another thing, what if we heated over this object or the solid thing? Guess like you have an ice. This is a cube of ice, so it's the particles all tightly packed together, and they also vibrating only in their place. I mean, they're not not have a random, not have a faster place. But you know why? Because they already tightly packed. I mean, like they're sticky together, so they don't have more space to move through. But if we heat it over, now we give them more energy, and the particles in size become a more heating over and more faster because they gain more energy. And the energy they took, which is like a heat energy, and this thermal energy or heat energy they took, it just converted into kinetic energy. Kinetic, it means like a motion, and now their motion becoming increasing. So when you got a substance and this substance, you hit it over a solid, hit it over becomes more faster particles, which is changed into liquid. And what does it mean by the liquid? The liquid object, which is have a faster motion between its particles, and all liquids particles, they got a far part of each other. No, the all liquids by the random motion and faster speed. Understand it?
Yes.
And actually, because they have a random motion, so they have a random shape. I mean, like they have indefinite shape. I mean, it's like water or milk or oil. If you put it in a cup, whatever the shape of the cup, they can take it and form the same shape of the object. Got it? So here, when you got a liquid, this liquid, it's become like water. When you pour it in any place, you put it, it just taking the place of or the space or the volume for the container. But the volume, if I told you like its shape, it's like round, it's gonna take the shape, rounding shape as the container if it is. So it means like it has indefinite shape. But its volume, if I got a liter of water, still could be a liter, whatever you pass through, because its volume doesn't change, still liter. Got it?
Yes.
Just like we heat it over, we got it more heat and we heat it over. So now we give it a thermal energy more. What? Guess what will happen to the motion for particles?
Will it become a solid?
The motion. Now we increase
Oh.
heat.
Will it become tightly close together, or
They already close, but will they move faster or much slower?
faster?
Faster. So now the particles were here moving just slow, and here increasing heat make them moving faster. Adding more heat will increase the speed, right? Right?
Yes. Yes.
Yeah, so it's gonna increase the speed of particles, so they're gonna make them more random. More random, I mean, could be like this. It has a very far away distance between each particle and the other. So again, from the solid, all particles are completely stuck together. After a while, all particles could be like it just somehow all particles have a faster motion in gases. Once you see now each particle can move alone in its own pattern, it doesn't have the all same pattern and same shape. No, each particle have its own pattern. Just like deer, when they have a pattern of motion, fast motion, each particle has its own direction and pattern. And then what can you find? They are speed and then random motion, each one has its own pattern direction. What conclusion? It must have a collision. So the gases particles can collide together, and they are also have indefinite shape because you can fill a balloon. If it was like a heart shape, could be take the same shape. If it was like round shape, square shape, the balloon's taking the shape. Whatever you fill the gas, it just taking the shape of balloon. So it means like it has indefinite shape. About an indefinite volume, we have just like I got you a four types of smaller and a smaller container. And I want to add like a gas particles in it. If I got four gases, you know that all these four particles can take the four gases particles. Here, first one can take the four gases particle easily. Second one can take them, but they're gonna be somehow closer than each other. The one other also can take it, but somehow much closer. And the closest particles could be in number four. Why? Because in number four, it doesn't have much space, but the gas in these cases could be compressed. Compressed for first case, second case, they are somehow more compressed. Compressed, I mean like the intermolecular spaces between them. Here, look for the spaces between each particle and the other, somehow long spaces. Look here about the intermolecular spaces, somehow shorter because we got a smaller volume, but still can take four particles. And here for the last one, the spaces become more short. So it means like it could take the four particles, but they could be somehow compressed more. Once they are compressed more, so that's become you have a smaller place, a smaller distance, till they are compressed the most in case four. So in this case, it means like the same four particles can occupy each volume, whatever is the volume. So the gases, they have a definite shape, indefinite shape because they can take the shape of the balloon, whatever is the shape of it. At the same time, it has indefinite volume because it can fill any volume with the same amount of particles. And this is a unique property for the gases because all gases can take the shape, it's okay, like liquids, but only gases, it can take an indefinite volume. I mean, whatever the volume is, it will occupy it by being compressed. Understand it?
Yes.
So this is the motion for the gaseous particles. They can move everywhere. Random motion. Focus in a word which is mean random motion. And that's because they have a very far spaces between each other. And these spaces, which is make them indefinite shape, at the same time indefinite volume. Understand it?
Yeah.
So now let's change between these three states of matter. Listen here. If you got melting, put in yourself in an example. If I told you I have an example for, and this example, which is an ice. Guess like all examples or questions, they are related to this example, which is an ice. I have a piece of ice, which is solid. If it changes into liquid water, and then we call what happened to the ice?
Is it gonna melt?
Yeah, they're gonna melt. When the ice melts, so in this case, it just getting more heat, so changing from the solid into liquid while melting. Next one, If I have a water and it's trying to increase heat more and give it more temperature, if you give it more temperature, so in this case, cold, like I have a piece of water and I boiled it. If you boiled it, it's gonna make vaporization or boiling, evaporation from the water now become a gas. So guess now if I have this water and I want my ice back again, what could I do then?
Hmm?
A water and I want it to be an ice back again. What could I do
You can,
then?
you can put it in the freezer.
Yeah, we can put it in a freezer. So in this case, we can change from liquid water into solid. It become freezing. So the all gases particles can change like this, move freely and random motion. All liquid particles, they can just moving like random, but they have still somehow close to each other. They have an indefinite shape but definite volume. Here, gas, like I have this gas and I want to change it into water. You know, with what? The cattle lead example. Remember? The cattle lead example. We put a lead over the cattle, and when you remove the lead, what you found, I see some droplets of water. These droplets of water, this make condensation. Understand it?
Yes.
What if what means by sublimation? Remember, when you see sublimation, so it's changing from S, which is solid, into gas.
Yeah. Yeah.
Yeah. Do I here, in this example, do I have the liquid state in it, or it doesn't pass through liquid?
Hmm? In the
In yeah, sublimation.
um
Do we have
no,
liquid?
it's directly a solid to a gas.
Yeah, so it doesn't pass through liquid state.
Yeah.
Well, so now what if we heated the gas over million degree? Over million degree, now you have a plasma. This plasma, when you have ionized gas, I mean like heating the gas more and more. Got to understand the three states of matter and the differentiate between them.